This is the Algebra 1 Summer School, Unit 7, Lesson 2 Notes video. This lesson is on exponential models. All right, so real-world applications of exponentials. To review, before we start getting into the exponential models, we have the general form of an exponential model, which is y equals a times b to the x. Remember, the number in front, a, is the initial amount. That's the amount of something that you start with, and b is the amount you're growing by. We had whole numbers, so if we see the words doubles or triples, quadruples, quintuples, things like that, we're going to use that general exponential model. Now, an extension of the general exponential model looks like this. A sub 0, 1 plus p to the t, and a sub 0 times 1 minus p to the t. This is just percent increasing and decreasing. All right, the a sub 0 is just like your regular a. That's the initial value again. 1 plus p is like your b. Same with 1 minus b. P is the percent that you're increasing or decreasing by, that you either add or subtract from 1. We will go through examples with all of that. Let's jump right in. It says for each question below, determine if the situation is exponential increase or decrease. Then choose the correct model setup and evaluate the situation. 1. Write an equation that gives the savings in an account if $250 was invested at an interest rate of 3% per year. Then determine the total amount in the account after 12 years. Well, let's see. If I put money into a savings account and it's earning interest, that means the amount in the account is increasing. So this is exponential increase. When we're choosing the model, if you see somewhere that there's a percent, a rate of 3%, that's going to be one of these percentage problems here. Since I'm increasing by a percent, I'm going to choose the model that's 1 plus p. Now for my model setup, it says take the savings, so S equals. Now remember, when I have an exponential model, the first number that you write down is the amount you start with. Our account starts with $250, and then we have to figure out the growth rate. Well, we have percent, so it's 1 plus 3% as a decimal is 0.03 to the x. Now, you can rewrite this if you want to, you don't have to, as S equals 250 times 1.03 to the x. These are exactly the same. I just added together the 1 plus the 0.03, but they are the same equation. Now, I want to use that equation to figure out how much money is going to be in my account after 12 years. So I'm going to take that equation, and I'm going to put 12 in for x. I'm going to type that into my calculator, and you should end up getting $356.44. So I put $250 in an account, it earns 3% interest each year. After 12 years, I'll have $356.44. Next, if the population of a town is decreasing by 4% each year and started with 12,500 residents, what would be the projected population in 10 years? Show the setup of the exponential model you use. Well, we already know that it's going to be decreasing because we say that the town's population is decreasing by 4%. Again, I'm given a percent here, so I'm going to look at one of the second models, which uses 1 minus p, 1 minus the percent. So for our equation, we have p equals the population. I always start with the amount I start with, 12,500 people, times 1 minus 4%, which is 0.04 to the x. Now, I can totally leave it like that. But if I wanted to, I could rewrite this equation as 12,500 times 0.96 to the x. Those two values, 1 minus 0.04 and 0.96, are exactly the same. They're just rewritten. Notice that this 0.96 looks like an exponential decreasing model. Remember, we always talked about back in the exponentials unit how this value, if it's less than 1, is decreasing. Now let's use that model to figure out the total amount of people living in this town after 10 years. So take the population equals 12,500 times 0.96 to the 10th power. When I do that, the closest whole number of people is 8,310 people. So after 10 years, we'll be down to about 8,000 people in the town. All right, flip your page over. Let's talk about some zombies. Zombies are invading Delaware. Initially, 24 zombies come to town, and the number of zombies triples each day. How many zombies are there in a week? 7 days. Well, if zombies are coming and the amount of people are tripling, that means it's going to be exponential increase. Now, because we're just tripling and we don't see that we're growing by a percent, I'm going to use just this kind of exponential general model here. My model here will have y equals, we put the starting amount of zombies first. Tripling means you're multiplying by 3 every time to the x. All right, now to find out how many zombies there are after 7 days, I put 7 in for x. When I do that, I end up with 52,488 zombies. That's a lot of zombies invading Delaware. So I started with 24, and after a week, there's 52,488. Now, let's shift gears a little bit. Those last 3 problems, we were writing exponential models. Now, I'm going to give you an exponential model, and you have to identify some information about it. Number 1, the value of a car can be modeled by the function v of t equals 27,000 times 0.89 to the t, where t is the number of years since you bought the car. First, is this growth or decay? Well, to do that, I'm going to look at the number in parentheses, 0.89. Because the 0.89 is less than 1, this is exponential decay or exponential decrease. The rate that we're decreasing by, we have to be really careful. It's not 89%. This is one where we had to take 1 minus that percent, remember, because that's really 1 minus p is 0.89, and figure out the percentage rate. That ends up being 0.11, which is 11%. So that means that your car is depreciating, going down in value by 11% every year. Now it says, what's the value of the car when you bought it? That's the initial amount, $27,000. Now, what's the predicted value of the car 5 years after you buy it? Right? Show the setup that leads to your answer. So the value of the car after 5 years, v of 5, t is 5, equals 27,000 times 0.89 to the 5. That's the setup of your equation. When I put that in my calculator, I can find that the value of the car is $15,076.96. So you buy it for $27,000. 5 years later, it's worth $15,076. Number 2, the amount of money you lend your sister is modeled by A of t equals 140 times 1.08 to the t. T is the number of months since you started loaning her money. Is this growth or decay? Again, I look at the growth rate here. It's 1.08, which is greater than 1. So this is exponential growth. Well, what's the growth rate? Well, it's 1.08, so that is like 1 plus a percent. The percent is 0.08, which is 8%. So your sister, you are charging her 8% interest on her loan. The original amount of her loan is the starting value, $140. So you lend your sister $140, you charge her 8% interest, and she doesn't pay you back for 10 months. So now what's the predicted value of the loan 10 months later? So I'm going to find the amount after 10 months. A of t equals 140 times 1.08 to the 10th power. That loan after 10 months is going to be $302.25. Now let's put this to practice this in some OST style questions. All right, these are Ohio State test questions. First one, it says a scientist is studying wildlife. She estimates the population of bats in her state to be 270,000. She predicts the population to grow at an average rate of 2.9%. Percent is really key here. Using the scientist's prediction, create an equation that models population of bats. Now, the percent is our key word as to, one, how we're going to set up the equation, but also to know that this is going to be an exponential equation and not a linear equation. When I write my equation, y equals, I always start for exponential with the amount they told us we start with, which is 270,000 bats. It says the population is growing by 2.9% every year. So that means my model has to have a 1 plus. Now, 2.9% is 2.9 over 100, which is 0.029. So that's what I need to put in my model. 1 plus 0.029 to the x. Just as before, if I want to rewrite this, I can definitely do that. I have 270,000 times 1.029 to the x. All right, second OST question. The population of rabbits on a large island doubles every year. On January 1st, the population is 150 rabbits. Which equation can be used to find the number of years it will take the population to reach 4,800? All right, so the 4,800 is just what the equation is going to equal. So those are all the same for every problem. Now I have to decide, is this a linear or an exponential problem? I have both. This would be a linear equation because there's a plus sign. This is exponential because there's multiplication. This is linear because of the plus. And this one's exponential. Well, if I'm saying that something is doubling, that's always our key, that it's going to be exponential. So I can go ahead and cross out the linear equations right away. Now, it says we start with 150 rabbits and double. So that means the 150 is the starting amount, which always comes in front of the number that you're multiplying by, which means D is going to be my answer. That's 150 times 2 to the x. All right, last one here. A landscaper put 5 fish into a new pond. The number of fish doubles each month over a period of time. Write a function to model the number of fish in a pond after 10x months. Well, we know we put 5 fish in a pond. That's our starting amount. The number of fish is doubling, which means it's getting multiplied by 2 to the x value. That's it. That's all there is to writing exponential models. Go ahead and try the practice that's posted on Canvas. Watch the video if you need it, or come in for office hours for extra help.